Good morning, good afternoon, good evening, everyone, depending on which time zone you're in. Welcome to the AIX Education webinar session. I'm Sophie, the webinar lead at AIX Education. We're very excited to have you all here today. AIX Education is a student-run initiative that brings together K12 and higher ed students, educators, researchers, and edtech entrepreneurs to collectively explore the future of ubiquitous AI in education. We host conferences, webinars, and bi-weekly newsletters to share the latest discussion and research in the field. Today's webinar is very closely tied to what many of you might be interested in. Together with Mike, the webinar will focus on identifying specific education tasks where GPT-style AI model might falter and the potential unintended consequences of their deployment. On that note, let's welcome Mike, our award-winning public school teacher, principal, superintendent, and AI researcher at Stanford.
Thanks, Sophie. And thanks so much for having me. This is a topic that I feel very strongly about. I'll share my screen and we'll jump right in. Can you, just making sure, can you see the screen okay? Okay,
Yes,
great.
we can see your screen.
Right. So, a quick thing about me. So I'm an educator. I've had a long career in education, but I came back to get a PhD because I believe maybe this time it could be different. I am someone who has been unimpressed for the last 20 years of ed tech. And I don't, not very much impact. And so when AI started developing, I thought maybe this time could be different. So my research is actually building these models and testing these models. That's what I do because I'm interested in finding, can we make something that will help? And hopefully we're going to be able to identify even more clearly which education tasks these GPT-style AI tools are going to be more likely to fail at, what it is that we mean by fail, and how to recognize. Oh.
Mike, okay, awesome, we're back.
Can you hear me?
Yes.
Can you see my screen?
Yes.
Okay. As long as you're okay. My wife connected something to the Bluetooth and stuff happens. All right. Okay, so here's to get us started. Here's an example. So I gave this prompt to GPT. You're an accurate and helpful writing bot. So this is going to be something looking at grading a student's essay. In this scenario, you're going to provide a numeric rating. I give them the essay, I give them like the instructions that are given to students. I give them the instructions for grading. And I end the prompt with, this written response was created by a student in Mrs. Jones's class. Actually, Mrs. Jones's third grade class, but provide a numeric rating from 0 to 2 to classify the quality of developmentally appropriate conventions. But I did something where I replaced that star with white and with black. And that's so I ran this prompt twice, just back to back. I just said, it's a white student in Mrs. Jones's class and a black student. It gave different scores. Okay, that shouldn't happen. But what's also interesting is like, hey, maybe it gave some feedback that's good if we like maybe there's something that I don't know. How do we interpret this? So each chunk of feedback had 4 bullets and an overall. On the left is the feedback to the white student, on the right is the feedback to the black student. So there's like different things that are highlighted in spelling and grammar. Like they found one more. I've highlighted the differences on both sides in the highlighting so you can see the differences. I'll let you see the tone difference. On punctuation, you'll notice that like this is the exact same prompt, found the exact same thing. Here's an interesting one. So on capitalization, it got the exact same bullet point, but read that and see why this is also a problem. Can anybody put it in the chat when you figure out why this is still a problem? I can't see the chat, but let's see. Did anybody? Let's see if I can see anything in the chat. No. Let's see. It is identical. Yes. These are all true statements. What is the feedback on? It's on capitalization.
Yeah, but it's not giving capitalization, it's giving
Yep.
and word choice, spelling.
Exactly. It's not doing capitalization. So like, yes, it gave the same feedback, but it wasn't good. It wasn't even accurate. Finally, let's see, clarity and coherence. Notice like a difference in word choice. And the overall section. Now, so this was identical. Obviously, the real model is GPT, real results. Obviously and absurdly unethical. And some might be able to say like, oh, it could even have been considered an example of personalization. I'm using learner or user information to inform the model. Personal, you're like, so what went wrong? And how do we even start to address something like this? Is the question. And the rest of this talk is going to be diving into that. And what I'd like to do is invite folks to, chime in, drop things into the chat as they see observations or questions that they have. I'd like to keep this kind of free flowing, and I'm happy to go more technical or less technical as we go. Right now it's planned to be more technically light, but I am going to frame it around a recent paper that is looking into the same question from a kind of a, not education stance. We're going to do the education interpretation, but paper McCoy et al. Being able to reason about when LLMs will fail at a task is critical as these systems become more widely deployed. That is the thing. So, and modifying the quote a little bit, being able to reason about when it will fail at education tasks and why it's actually harder to identify when it will fail at education tasks. So here's what we're going to do. We're going to talk about what we mean by fail at a task, reasoning about when LLMs fail, and then we're going to talk through some tangible examples of how it fails and how to identify, like, what are the characteristics of some of these classical examples. So we're going to start by talking about, okay, what does it mean to fail at a task in education? How good is good enough? So we just looked at those third grade essays, and maybe there are questions that we could be asking ourselves, like, so what's the maximum amount of third graders that we're willing to receive that feedback from ChatGPT? How many would we be okay with? Or maybe on average, an AI tool helps students, even if it messes up only occasionally. What's the ratio? How many children are we willing to mess up? Now, but teachers mess up too. What's the difference between a teacher messing up 5% of the time and a model messing up 5% of the time? And if we know a model messes up 5% of the time on task A, what are the consequences of asking it to do related tasks B, C, and D, whose true impacts we might not be able to easily measure? To talk about some of these things, so I don't have answers to these questions. Obviously, these are kind of just rhetorical. But to kind of warm up about this idea of how good is good enough, let's start with an example of just like a human tutor. There's a big interest in personalized learning because Bloom's Two Sigma. So Bloom, back in '84, for those of you who aren't familiar with this idea, is found that the greatest gains came from individualized tutoring based on mastery learning with a teacher. That was the greatest gains to a student's learning. And if you've got a human tutor, there's with 10 students here, an excellent tutor, all of the students are learning at their maximum growth potential, whatever that is. But like human tutors vary in their impact on students. So like maybe a less good tutor might not reach every student, some might struggle a little bit, like they vary in quality. And so I'm going to be using the term quality to just generally represent this idea of its relative impact on students. But like in 94, Vauquel proposed the negative 2 sigma. Like there are cases where like doing not that thing would actually be like have a kid doing a worksheet could do better than some instances of poor teaching. And I don't want to say that that is very much the case, but like the point is that human tutors vary in quality. There are good ones and there are bad ones, and who they are able to connect and get to grow at their maximum potential may change. There's lots of variables at play here. And so I want to use this kind of example to frame a couple ideas. So first we'll say like equality. So equality can be viewed as equal access. So well, actually there's 50 of these, but all 50 of these students have equal access to a tutor. They all have a tutor of some sort. And equity we'll just define as equal access to the benefits. The tutor quality may not be equitably distributed. However that means, it could be that the varying qualities of tutor make it very difficult to do this, but the point is they're not getting the same amount of benefit depending on the tutor that they've got maybe. And we'll talk about, we'll just mention marginalization, because this is the big thing that we're going to be asking ourselves as we look to see whether or not these models and tasks are going to be good at an education task. Which students benefit and by how much it will change. Like who's a smiley face and who's a frowning face may shift and change as we work on these things. So human tutors, like we said, vary in quality. But this isn't just human tutors. Curricula, they vary in quality. Classroom climate systems and how they motivate students vary in quality. Lesson plans, they vary in quality. Specific learning activities vary in quality. And AI tutors will definitely vary in quality. And additionally, AI tutoring, AI curriculum, AI learning activities, AI lesson plans, AI intervention plans, AI worksheets, AI quizzes. They will all vary in quality. And so this is the framing I want to have us be thinking about as we talk about like places in education where these things are going to fail. AI failures in education are usually a failure to be at the level of quality demanded for the intended use. It's usually not a yes/no thing, like can it or can't it. It is a measure of extent. And so there are a lot of like basically if we ask GPT to do any task, it won't tell you if it's not good enough or it doesn't know how. Well, any education task can't do lunch duty. But we might need to rethink this idea, because a lot of times in public discourse, people are like, AI hallucination. If we fix whether or not AI can get things right or not, then that is the solution that we need. That's the solution that we need to make it sure it's good at being education and stuff like that. It doesn't say something wrong, but that's not good enough. Because it isn't about being factually correct. How do you prove that a lesson plan is just better than another one? I mean, there are ways, and many people on this call may have ideas of how to quantify that, but for the most vocal advocates of perhaps AI tech, they may not have that same level of nuance. And that brings us to the word of the day, ultra-crepidarianism. And this word I learned only recently. Offering expertise or acting authoritative in topics in which one is not expert or authoritative, because this is GPT. So ultra-crepidarianism, wonderful word, and it means exactly kind of the thing that we are working on, and it also so hooray, word of the day. Right now, the solution to this, to ultra-crepidarianism in these models, is to just say, hey, everybody, we'll keep a human in the loop. GPT can make mistakes. Check important stuff. You know, Conmigo makes mistakes. Claude can make. It's basically to say like, don't blame us. It just, we know it's not right. But that's not how people use these tools. You know, and it brings me to this paradox that I've invented until somebody on this call can tell me if this paradox exists somewhere. I call it the free consultation paradox. Like, people needing more guidance are also those that are less discerning of the quality of the guidance or support offered. It's a very obvious thing for like why, you know, people are like, tell children, you know, like, not everything on the internet is true, because they're not very discerning. They need lots of guidance, and like, information is presented to them and they're not very discerning. And this is the case with adults as well. Those needing more guidance are going to be less discerning. And why this matters for the production of these tools in AI is the people that need the most help or the least able to recognize these qualitative failures. So it does matter. And the idea of just like, look, it made a lesson plan versus it made a good lesson plan. A struggling or a new teacher may not be able to recognize the difference, and yet we do it anyway. So, and the challenge here is like, it is a hard thing to convince people about these tasks in education. And this one actually is my quote, so I can put my name there. But I say this all the time: education is the only discipline where every person has an opinion and they all think they're right. It's the only, like, you won't hear about engineering, about plumbing, about anything. This is the only place. And it makes it challenging because, like, people look at everything that GPT writes as plausible. And so it's hard to say that, like, there's a quality difference that is meaningful in some of the things we're talking about. So let's talk about how the reasoning of when LLMs may fail. And we're going to look at it from the paper that we started at the beginning. Is failures can be understood directly in terms of a conflict between what the model was trained to do and the task at hand. And this paper by McCoy, we're going to use that to frame some stuff. And we're going to, I'm a teacher, so you already got a word of the day. You're also going to get an equation. What were they trained to do? Auto-regression of internet text. This is what they are best at. This is what they were trained to do. And the discrepancy between that thing that they are best at and the tasks we ask it to do are help to explain. So let's break this down. Autoregression, scary word. It's a statistical objective that just tries to predict what comes next based on what came before. Another way to write that is, model, you should guess the most likely next word based on the text and prompt for this task so far, and everything else that you've seen when we built you from the internet, all the data. And that's, those colors correspond to the pieces of the equation. So this equation and this relationship tell us a few things that it's not going to be very good at. So one is like planning and course correcting. They can't plan ahead, and they can't course correct. If you type in something weird or it types in something goofy, it will assume that it needs to predict the next word based on that previous one. It doesn't question it. So like, an example for like working with a child, if a child asks a confused question, it will assume that the question is not confusion, that it's legitimate. Like they're asking the wrong thing, and it will give an explanation if you ask it to do something dumb. So like, there's a lot of stuff that we do to try to make these, to learn to work with these models. Prompting. Prompts are a small part. When you prompt ChatGPT, uses your prompt and everything before includes the internet. But basically what the prompts are doing is they're trying to teach the model to find the patterns in all the text in the internet that it has seen before that are going to be, that seem most relevant, so it can make a prediction about what the next word is going to be. And so prompt engineering some of these problems can be mitigated if we do very kind of sophisticated prompt engineering. We write very prompts that help to guide the away from some of the common mistakes, step-by-step thinking, so it does its planning manually. And most providers have like hidden prompts and stuff to help users to make it a better experience for them. But the problem like with prompting and stuff is you can you can jailbreak these things. So you can have the LLM forget about the prompt. But the thing is you can't make it forget about it, all the internet of text. It still will say things. You can't make it forget everything. You can make it forget just the most recent stuff, but the stuff that's stored in its like little AI brain, that stuff you can't make it forget. You can prompt to avoid it, but you can't make it forget it. They are probability machines, and they make predictions based on what seems most likely, based on all the things that they've seen, and they've seen a lot of things. This is why they can explain rocket science, but why they can't grade a third grade essay. So that paper by McCoy et al., they focus on three things, and for simplicity, they've got 7 different kinds of situations where these kinds of GPT-style models will struggle. We're going to focus on the main 3 of that paper, but we could talk about more of them if we want. So they hypothesize and test and show that things that are rare, and we're talking about rare in terms of the task being asked or the exposure to relationships within text that are found throughout the internet, are going to be just harder for it to do in general. The rarer or weirder that task is, the harder it will, the harder it's going to be for the model to do it. It's not to say that like everything's impossible, but it is, we can say something about like whether or not it's going to be very natural for the model to do it, or whether we think it might just struggle. So prompting may not be enough. And we'll go through some tangible examples here in a second. We can't always say whether AI tools could do a task well enough. Recognizing tasks is hard. Because if we're really good at prompting, we can kind of get it to do some really incredible things. So how do we identify what is just outside of its reach, and what is way what is something that if we did enough prompt engineering, we could come up with, we could get it to do the thing that we wanted to do. So we're going to start with some tangible examples aligned to AI research. I'm going to pose this question. Some of you may or may not know this thing. So these things are large language models. They are language models. When GPT-4 was released, they released its performance on a bunch of tests. These are all these tests like LSAT, stats, AP Calculus, and AP US Government, did all these things. So, and from GPT 3.5 to GPT-4, the improvement is in green, how much better it got. So there are a couple AP tests, 2 AP tests that it did not improve at all, and still failed miserably, can't pass them. They're AP English Language and AP English Literature. The thing that it's called a language model. So one might expect, oh, it's language, therefore this should do well. No, it's actually really bad at it. It's terrible, because the issue is it doesn't, like AP English Language and AP English Literature isn't necessarily about memorizing. You're asking, it's more asking people to think about the language or text or whatever. And these models can't think. What they're going to do is they're going to give you the most likely next word, and then do that again and again and again. And so even though the most state-of-the-art machines can pass all the other AP tests and pass the bar exam and pass
4 halves of an onion.
What's that? I didn't hear. Oh, so that was like, I wanted to frame with this is that it is known that these models can't do everything. The people that work on these models know that they can't do everything. And I'm going to hopefully give enough technical details about each of these different tasks and things and how to identify them that hopefully we'll walk away with at least a little bit more insight into where it's going to be better or worse. So first one we're going to talk about is coaching teachers, or coaching and supporting teachers. There's lots about teacher feedback and trying to support, trying to support and develop classroom teachers. Now this is we're going to call a rare task, and rare tasks, I had a hard time defining this, but it's not like some weird task. So it's not like, oh, write me a country song about dwarves making a peanut butter and blueberry casserole. Like, yeah, that's not on the internet, but like that isn't a rare task. There's many examples of stories. There's many examples of like writing things. Rare tasks have more to do with, I mean, interpreting from what McCoy and all was doing into the education sphere. It has less to do with like how weird the task is. It's how common is the relationship between what is being offered in the text and what it's supposed to be doing. How close is that relationship found throughout the internet? So because there could be examples of lots of people coaching and giving advice to teachers, and there's lots and lots of that. But in this case, we're going to talk about specifically, like, there's interest in automated feedback and improving teachers and based on their teaching. And guess what? There isn't a lot of on the internet. There isn't a lot of like transcripts of classroom teachers talking. There's some videos, maybe. And there's a reason for all of this. Is children's, like working with children, it's protected, and so it's hard. There's lots of permissions that are required to put things on the internet, and so like this is not a task that we see a lot of. Now the good news is all the examples that we're going to be going over, I'm going to give you some at least a little bit of quantitative stuff. So let's look at this the idea of giving teacher feedback. So and this is similar to giving a teacher or student feedback in some ways on like an essay, but what typically happens is when a teacher is observed, teachers teach a lesson, there's some kind of framework or shared under like rubric maybe that an administrator is using as they go in to a classroom, and that observer will like maybe rate and look for different areas of instruction and prioritize which of the areas are going to be most important based on, you know, some set of criteria, and then work with the teacher around that specific thing. So implicit in coaching a teacher or supporting or helping a teacher is the ability to see all of the things that could be coached on and choose the ones that are most important. I will tell you right now, these models cannot do that. There's no examples of that online. So we're going to take the smallest thing, which is, can they at least identify the level of, you know, coaching or ability of a teacher, and have the then let the prioritization happen with an administrator or somebody else. So this is going to be a quick data set. This is what we're going to look at is LLM's abilities LLM's abilities to rate on an instrument called the MQI. It's mathematical quality instruction across a bunch of 1,000 different classroom transcripts. They're going to look at what is said in the classroom and see if they can provide ratings like a human can. And so here's an analysis that I run. If you guys are into psychometrics, I can give you some of the measurement stuff here. But basically, we're going to look at a graph, and along the bottom is rater bias. So on the left side of the graph are going to be more severe raters, raters that are that grade a little bit harder. And on the right, we're going to see more lenient graders, not people who may like some rater that is a little bit easier. And we're going to see three different things on here. So we're going to see all of the humans that rated individually. So each point is going to represent an individual human rater on they watched videos. They didn't read a transcript, but they watched videos. And there are some models that I built. We're not going to talk about them. They're the little dot ones. So I circled right there. There's like 5 little dot ones. Those are models that I built. So like, if we care about it, like getting things right, we can build language models that can do stuff. And we're going to see GPT. The problem with the GPT ones is, where are they? We need to zoom out because they are way out here relative to everything else. Like GPT is terrible at this task, at coaching teachers. This was granted, this was the 3 different prompt engineering styles in a different paper. I should have put them, Wang and Dembski 2023, but so they tried to use it for coaching teachers, and it's objectively very bad. But when we coach teachers, this is like the overall rating. So let's look at like an individual thing. Can it identify, for example, how well a teacher is remediating student errors? Because maybe we could help them with remediation, we want to be able to do that with tutors, right? So how well is a teacher remediating errors? So on a specific question, on the left, again, it's more severe graders. On the right, it's more lenient. We see on the right, these little triangle things. Those are the GPT prompt engineered models. They gave them the instructions and what they were looking for, the transcript of that part of the lesson, and asked it to like give a rating. Well, it turns out like they're very, very lenient. But here's the more interesting thing. We're going to look at the same chart again, but this time the model was fit for rater effects that include the race or ethnicity of the teacher. So our like how much on the left side will be scores or raters that are more severe scores for Black teachers versus white. And on the right would be raters who are more lenient in their scores for Black teachers when compared to white. Now, this is not information that the LLM has access to. There's no place in there where it's like, this is a white teacher, this is a Black teacher. But there is a difference. And the contrast between the graph on the left, where it's all super, super lenient grading, and the graph on the right, where we see that 2 of the 3 prompt models resulted in clear bias in the other direction. And that's non-random. Like there's these little confidence interval bars in there that are hard to see because they're small. But so what do we make of that? Like, how did it figure it out? There are recent papers came out in the last few months that started exploring the same idea, not in education, but in medicine, where like biases are starting to emerge. And they can identify them and detect them. But like there are biases, and sometimes they don't act the way that we would have expected. And for a quick one more thing here is another study we can do. For those of you who are familiar with generalizability theory, this is called a decision study. And basically, it answers the question, what kinds of things can we do that might improve the reliability of the scores that we give a teacher about their teaching in this case? And so people would call this like human in the loop. What if they just use GPT? What if they use GPT alongside a human? And we can estimate how it would what would happen. It turns out, so this bottom line with the blue dots, I should have gotten a higher quality one of it, but You can see that that blue line, that represents GPT. The black line represents a human by themselves. The red line represents an additional human, so like 2 humans observing classrooms. The top 2 lines are models that I made, but like the key thing here is that it's not just that GPT isn't very good, it's that if you use it, it will make it worse. Like, it's not about like, just use a human in the loop and it'll be fine. Well, if somebody believes the things that GPT is saying about a task that is so far afield, like it will actually make things worse. And if they can't recognize that there's a difference in quality, because here's the thing, you read the literature on automated feedback to teachers and stuff like that. It's just like, you can find examples of it, like GPT will explain itself, and it seems so plausible unless you've coached teachers. So next, we're going to look at automated grading. This one falls into this category of rare inputs, because like there are lots of examples of good essays and even learning standards for writing. Lots of people online that solicit feedback for writing. So there's lots of cases of like seeing lots and lots of writing, right? However, there's not a lot of actual children's writing. This is part of the reason why a lot of the research focuses around post-secondary, college level stuff, because where you're not working with people who are developing their own way of expressing, right? We assume that people write, well, I'll make a claim that I don't have evidence to support, but like the way that a child who's learning to write, the way a child writes is different than an adult that perhaps has a like a 3rd grade education. They write differently. And here's an example of an actual 5th grade essay, or just a section of it. And the thing is this kind of writing is not found on the internet. But there just aren't examples of it. There aren't very many of these. And you know, if kids are writing online, they're not writing essays generally. Let's just say that. So there may be examples of children writing, but to be able to make sense of that. So anyway, the point is, this is a rare input. This is the kind of writing it's not going to see very much of. So its predictions are not going to be very good. And so let's kind of contextualize this grading thing, okay? So this graph that we've got here is a graph that shows all of the tests that are used commonly. They're called the benchmarks for AI models. This came from contextual AI and Dynabench is a paper that tries to measure the performance of all these powerful models. And on the x-axis is time, and on the y-axis is how far off from human performance are the different models on these tasks. And by the advent of like GPT time around 2020 and stuff, you see that the lines are really steep. Like they create a new benchmark for these models, and all of a sudden they can do it. They can surpass human performance quickly, amazingly so. But a couple things about this. These tasks are not very much like tasks that are required in education. There's a purple one that says GSK8K, which has middle school math in it. But the tasks that are being asked of it are not the same ones that you would ask an educator or ask a student or whatever. The things that we are doing in these models and the way that we evaluate them are not exactly the same way that we would need to. But we would expect, given all these extremely powerful models on the far right that are like, they create a new benchmark, and within a year, they've surpassed human performance on it. Let's talk about one that isn't so good, short answer scoring. And so I plotted these little points on here. So there is a data set that was released in 2012 for grading short answers. The best LLM of any kind would appear where you see it right there on this chart. So that is the state of the art for this particular thing of grading short answers. And if we've got more time and people have questions, we can talk about why that might be. But keep in mind, a lot of it has to do with the weirdness and like the unusual inputs. Now, this is best LLM of any kind. What about the GPT style one, the ones that you prompt style ones? So that's the best GPT style one as of 2 months ago or a month ago or something. I think the paper was July. So yeah, a month. That's the best GPT style LLM, and they had to do a lot of things. They did some fine tuning. They did like they built a smaller version of a GPT style one that they could train and fine tune to do this kind of thing, and that's where they got. Now, where did GPT, the one that people actually use and would do things with, where's GPT on here? It's actually off the page. I kept shrinking the graph to try to get it so it would be on the page, but then it was getting hard to read. It would be really bad. Here's the crazy thing. The oldest LLM kind of system, the oldest languagey model type of thing is probably E-Rater. It is it was mid-90s, ETS, who runs the GRE test, built E-Rater, and it's been in continuous use since that time. Obviously, upgraded algorithms and things like that, but like even like we've been doing automated grading for a very long time. Now, granted, what ETS has to do to make their grading algorithm work, it makes it so it's not super transferable to other people's tests and situations, or else like we would have just said like, oh, let's just do what ETS is doing on everybody's things, and now it's automated grading. So, but we've been doing this for a long time. It's one of the older tasks than what's anything that's up here. But like, why is it so bad? Well, it has more than just the inputs are rare. There's a few other things that are important to understand as well. But the GPT style ones and their architecture and the specific problems that they struggle with makes it pretty hard for them to get this right. Because I'll summarize all the technical details in this like quick example. Its job is to predict the next token or the next word, whatever that is. And let's say you give it some kid's text where it's weird. All of a sudden, like the order of the words doesn't make sense. It like the model's ability to predict the next word as it reads the student's response gets worse. It gets worse and worse because it's not written the way it would have predicted. So by the time it gets done reading a student's response, like its ability to predict things after that has gotten a little watered down. And there's also a complication as well with something called tokenization, how the model takes in the words and turns them into numbers. The gap there also, that is also a gap that these models can't handle. So if you've got phonetic spelling mistakes, a lot of them can't figure that out. So for our final example, I'm gonna go over this one really quickly because this one we have enough time for questions or comments. But this last one is IEP generation, and this one you'll have to look forward for a research because I'm in the middle of this one. Just started recently. I chose IEPs partly because IEPs are legally binding. They are individualized plans for children, special education. They are, and getting them right is pretty important. I mean, I tell people that I wasn't a very good principal until I learned how to really do IEPs. That's when I became a decent principal of a school. Now, the thing is, there's lots of intervention plans and teaching recommendations online, personalized ones. So it's not really a rare task per se. And there's lots of people who have questions and recommendations for working with children who struggle. So it's not like it's rare inputs of people looking, saying like, here's a challenge that we want to work with. However, IEPs are doubly protected by FERPA and IDE. Like there are no, or very few, if any, real examples out there. It hasn't seen those kinds of things. It's seen things that we might think are similar. But because well, you know, my thinking right now is you could probably prompt engineer and get something pretty good. And that's what Khan Academy has done. Now, I'm going to conjecture that Khan Academy is doing as good as you can do with the prompt engineering that they're doing. They have an IEP assistant that creates individualized education plans. It comes up, it's written fairly well. It creates like recommendations and creates like suggestions for accommodations, and then goals, measurable goals, which is lovely. So I did the same thing that I did in our opening exercise. On the right, you can see in my IEP assistant, I said, okay, what kind of class is it? Third grade math. Disability category, I put in something that shouldn't go there. I did the same thing that in the opening, white, Black, Hispanic students as the disability category. So it didn't complain about that. It was like, okay, just accepted that. That's a problem. But again, these models can't think. They can only predict the next word. And so they, you know, don't question that kind of thing. I put it in disruptive in class, and then I put it in good in sports. And does it treat the children differently? Does it ignore? Because like I believe Khan Academy is doing as good as possible. So yes, it does do things differently. And you'll have to look forward to an upcoming paper about some of these things, because there's some interesting stuff that they do. For example, in the prompt that I just showed with disruptive in class and good at sports, the majority of students that like made up Black students were given accommodations or suggestions around leadership capacity and leading group activities, being like leaders. And some Hispanic students, 0 of the 50 or so white students were identified as having like leadership as being something that they could, a strength that they could use in either accommodations or otherwise. I should also say that like it's not very good at doing these tasks, but like, I mean, I guess it's as good as it can be with certain. It's not very good at understanding what is a reasonable goal or what to make sense of it, except for in very few circumstances, it seems. But I want to point out just one more interesting thing, because like, so obviously a teacher's not going to put in white, Black, or Hispanic. Like that's I'm doing something that probably people wouldn't do. But this is kind of an important idea. It's called data proxies. And the idea is tell me without telling me. Tell me you're an adult. So this was just copied and pasted from the internet. It's like this meme of tell me you're an adult without telling me you're an adult. I'll go first. Nothing excites me more than these days than seeing perfectly set homemade yogurt. Okay. So how would a model be able to tell, for example, that a teacher was Black if we didn't tell it? And those are data proxies. There are things that the models use for predicting the next word or next token that may in fact like be connected to things that we don't want it to connect, that shouldn't be connected. And why that's interesting is in this upcoming paper is I noticed a couple things. So I noticed that every once in a while, it would ignore the third grade math class that I gave it. Oh, it would give me an IEP for a 6th grade reading student when I was doing the above thing. So I changed this. So the disability, the current challenges, and the current strength of the student were all race ethnicity. So basically, I gave it no good information except for 3rd grade math. And it ignored the 3rd grade math, and it gave, whenever I did this, every single one, with an exception of maybe one, it came out with 6th grade reading. So it ignored the good information. So the question is, when it makes up this 6th grade reading student, does it ignore the rest of the bad information, or just does it ignore the only good piece of information? The answer is no, it doesn't ignore. The next question we should be asking is, okay, it makes sense that it wouldn't ignore, because if we change the word, then the probabilities and the way that it predicts the next token, we would expect it to write something different. But is it meaningfully different? Is it doing something where these made-up students that are now 6th grade reading students would somehow be being treated differently if they were Black, white, or Hispanic? And meaningfully meaning, are some being offered suggestions around opportunities or ways of measuring their performance that are different than their peers? And the answer to that is also yes. Even when the model made up a student, didn't use any of my information, made up its own student, and ignored 3rd grade math, and ignored it didn't ignore the race or ethnicity, and it showed up in 3rd grade, 6th grade reading in IEPs as looking like suggestions and goals. For example, there were statistically, the Black and Hispanic students are more likely to be recommended to use technological accommodations, some kind of technology assistive stuff, and so like things like noise canceling headphones or something, and white students aren't likely to get that as an accommodation, but they're more likely to get one-on-one with a teacher, and in some cases one-on-one with a peer mentor. And so those are differences, qualitative differences in the kinds of things that are being recommended. And so what do we take from all this? I would actually, instead of me summarizing, I would love to open it up for questions. This is my question slide, and somehow I forgot to write the word questions, so I'll just leave it as like this blank canvas of thought and ideas. But thank you, and I want to open up the discussion. And Sophie, should I I can pull up the chat if that would help, and I can also move to some of the, well, I'll just leave it on our agenda so people can help point me whatever they want to talk about. Do we have any questions, Sophie?
Yes. I'm looking at the most recent one. We have more comments along the way. We have Debbie asking, commenting, the 3rd grader writer, who is an adult, has much more knowledge or background than the 3rd grade child. And
Yep.
that affects the depth of comprehension in writing. I think this is a comment on the free consultation paradox.
I think it's also a comment on, Debbie, you're totally right. Because schema, when teaching ELA and reading and writing, schema plays a big role into how much a student can access and how they express themselves. So you're spot on about like why like children's writing would be very much different. I just pulled this up, and it looks like Rachel asked, all GPTs or just open AIs? So GPT, which stands for generative pre-trained transformers, basically any AI model where you are typing in natural language and out comes like natural language. You type in text and it comes out text. Those are the models that I've been kind of referring to as GPTs. When I showed you the automated, the automated scoring example, the best kind of LLM, the best one on this task was not a GPT one. So this was a model that doesn't do text. You don't type in text and get text out. You supply it text and it produces some kind of classification. It's a classifier. And so these other two are the GPT style. So when I say GPT style, I'm just talking about like the kind that has made this technology so incredibly prolific and accessible in ways that technologies like this have never been available in human history. The last time something this transformative happened, I don't know, was it the invention of like the atom bomb? And people don't have access to atom bombs. You know, it is a big thing. And the crazy thing is it's immediately available to everybody. And so that's, I focused a lot of my comments on those models, the ones that people are seeing, and not these kind of less chatty ones. Yeah.
If I may, I was asking about, you showed a graph of GPTs being like such an outlier in terms of bias. And I was wondering, because you had the OpenAI logo on them, I was wondering if those were, yeah, this one here, item specific rater bias. Yes, this, yeah.
So these come from, those scores come from another study. They used GPT only, and each of the little dots, the little triangles in this case, and here like the OpenAI dots, they use 3 different prompt engineering styles. So it was only ChatGPT what was available. So likely, my guess is because this task of like using classroom discourse, there's not a whole lot of analysis of classroom discourse that's broken down and that helps people evaluate what to make sense of it. So my guess is that there's very little that you could do with prompt engineering on any of the models to get it to do very well on this task. It's but like, here's the thing is nobody can say like it for sure can or cannot, but like the probability is pretty good that doesn't matter what kind of GPT language style model you give it, it would probably stink. I mean, to give the contrasting model, so like these little circles in here, these are non-GPT models that I built. So you can make a language model that can do these tasks, but it's not like the problem with this model, with my models is they're not like GPT and like they can't do things outside of rate classrooms. GPT can also give you a recipe for a cocktail and then write a love poem and then like create a reservation for a dinner and then organize something like and synthesize everything from all the papers about, you know, brain surgery for the last 40 years. So it can do all of these things. And that's why there's the immense popularity of these GPT models. Even though we could make models that could do stuff in education, people aren't. It's not as profitable partly, but there's other reasons too.
We are at time. We might have like 1 minute for one last very short question. And we have Joyce asking, will retrieval augmented generation improve this situation?
That is such a good question. So Rags, the 3 tasks that we identified around rare inputs, outputs, and whatever are ones that are based on the architecture and design of the model. So you can make a RAG, and what you will get is so a retrieval augmented model for people on the call. It's a language model that can go and make a query and find information that it needs in order to answer something. And for a lot of tasks, this is like the state of the like really cool state of the art stuff. But we would have expected, if the RAGs could do it, that RAGs have been around for 2 years. Why is this so terrible on like essay scoring? And part of the answer is like, I'll give you an example of one of the essays or one of the short answers that I gave it I think it was 6th or 7th grade. No, even if I gave exactly the thing that it kept messing up. So it kept messing up on the grading this reading thing, because in 6th grade, students have to be able to identify the difference, like a character trait, something that is stable versus like how they're feeling and emotion at the time. So trait. It could not grade correctly because it could not forget the general definition of trait and not the content specific definition of trait that 6th graders need to know so they can understand changes in traits over time. It could not get past it. So even when I told it explicitly, in this thing, trait is a permanent feature, not like an emotion, or like an experience, it could not get it right. Even so if I used a RAG and gave it access to some of these things, there are still tasks in education where it can't do it because it can't think, it can predict. And we can give it really good information, either through RAGs or through excellent prompting. But we know the kinds of tasks that it'll be hard for. So I think a lot of potential with RAGs and stuff like that. Like I can dream up in my head a way to design this, but I just haven't seen very much effort or push towards some of the ways that I think a RAG might be able to like help some of these things more.
Thank you very much, Mike, and thank you for the great questions. And we are at time, and that concludes the webinar today. We had a really great talk and insight from Mike. Today we discussed if you want to automate teacher support or grading with LLM, sometimes even with the best prompt engineering, that might still not be enough, even with human in the loop. Surprisingly and counterintuitively, the result might still even be worse. Then the question really need to ask ourselves is, how might we reason when LLM may fail at educational tasks? Thank you so much, Mike, and thank you to all of our audience who attended today's session. We are also open to any feedback. If you have any questions or feedback for us, please use the link in the chat. We would love to go over all the questions, but unfortunately, we don't have enough time today. So if you have any further question or things we haven't go over, please fill out the feedback form and we will make sure to send it to the speaker. If you would like to stay updated with our work, we have a newsletter that you can subscribe to. Thank you so much. Thank you, Mike, for a great talk. I've learned so much. I'm thrilled to learn about all the insights as well as the upcoming paper. Looking out for it, and wish all of you a great rest of your day.
Thanks a lot. And those who wanted to know the paper, this is the paper that I was citing at the bottom.
Thank you. Have a great rest of your week. Take care.